So is all about this is all about IR receivers or infrared receivers, however you want to call it, it's fine. So I'll be covering how it works, what it's made of, what it's used for, social implications of it, and what happens when it's thrown out. Keep in mind that IR receivers can come in many different forms, like this computer one, this one that's made for Lego, this one's that's made for receiving signals, just like how an IR signal should be do, but it's also in Lego. This is the most basic form of an IR receiver. So we'll be covering this, the most basic form of the IR receiver, because if we went to the advanced ones, there would be way too much to cover. So what is an IR receiver made of? So an IR receiver is basically mainly made out of silicon, copper, nickel and chromium in an alloy, carbon, and something called indium gallium arsenide. Now, the chemical formula for gallium arsenide is over here, and all the other elements are over here, and they have pictures to accompany them. So, what are IR receivers used for? Now, they have a huge amount of applications from toys all the way to AI. And for toys, they can be used for kids to power things like remote control cars. But for educational purposes, it's mainly used in younger grades. It can obviously used in older grades, but it's mainly in younger grades to keep the kids engaged. Like this Lego robot over here. I actually have one of these at home, and uh, they have they have robot programming challenges where kids build robots and compete with them, and they use IR receivers in here to do that. And it's used in the military for a new type of radar that's coming out, and it's also being used in the new Ripsaw M5 drone tank over here. So that will have huge effects on how the army works. It's also used in everyday devices and purposes, like a TV remote, for example. And it's also used in AI, where infrared sensors and infrared receivers are used to measure the proximity of an object and communicate with the controller. And so we move on to the first part of the IR receiver. The first part is the phototransistor. And this phototransistor is mainly made out of silicon or anything that semiconducts electricity and is dependent on a light source as a source of energy. Um, the phototransistor takes infrared light from the remote and uses the glass covering to amplify the signal and uses that radiant energy to provide signals and voltages to the rest of the IR receiver. So you could so this is the essential part of the IR receiver. The IR receiver all comes down to this. This is the main receiver. The rest of the IR receiver is the processing and output. Now a con of this iris of this receiver the phototransistor is actually it cannot handle anything more than 1000 volts. That's approximately. And the reason why I cannot do this is because the properties of the silicon that is made in here is specified so that it cannot go over 1000 volts. Um Otherwise, it would not be in the form that it has to work, and also because electrons are not allowed to move as freely as they are in metals as they are in uh, elements like silicon. And but some things that are good about it. It has a lot of good things about it. So one of the things that it reacts almost instantly to the signal because we're dealing with light and electricity here. They're almost instantaneous, and we're also dealing with silicon that reacts really quickly with light. Silicon that reacts really quickly, and the chemicals in here that react really quickly with it. And it's also really cheap. It's really cheap to make, and that's another good thing about it. And so the next piece of the IR receiver is the diode. Now, there can be many diodes in the IR receiver, but we're only going to be focusing on one. So a diode is a semiconducting device used to make a circuit go one way, right? And they're usually made out of silicon again, and but they can also be made of other elements such as germanium and compounds like gallium arsenide. And the reason why they use this is because they are all semiconductors because they're metalloids. So the way that these semiconductors work is that they have they are partially conductive and they're partially resistive. And they're partially conductive or they're partially insulative. So what happens is when electricity flows from from high electrical pressure to lower electrical pressure, um, the diode will allow the electricity to flow one way, but not the other. So when a current flows, there's going to be electrons traveling both ways, but if a current's flowing one way to another, that just means most electrons are flowing that way, but there will be electrons flowing the other way. So the resistance of the diode is low enough to let electricity flow one way, but it's high enough to not let electricity flow back. And this is essentially just to keep the circuit in check and so that electricity doesn't flow both ways and mess up the entire circuit. And about the wires connect from both sides of the diode to the rest of the to the rest of the circuit. Now these wires can be tinned copper or bare copper. Now I'm not going to get into what the difference is. I'm just going to tell you that there's two types. And the reason why copper is chosen here is because uh, even for a metal, copper has a really low resistance and loses electrons really easily. So it can easily let electrons pass through it both ways. And also because copper is less oxidizable than most other metals, so it makes it last longer and ideal for small devices that are hard to fix and very small. But keep in mind that copper is not found in large quantities, and here is just to connect up the circuit. Now, another part of the I receiver is the MOSFET, and this stands for metal oxide semiconductor field effect transistor. And the MOSFET is a device used to amplify electronic signals and a switch to decide when to power up this I receiver. And the switch part of it only allows certain currents to go through and it blocks other currents. So you can say it's sort of like a mini processor. And it allows the IR receiver to execute tasks only if the right amount of power or voltage is coming through. And again, this is mainly made out of silicon, but it also has other materials to make up the rest of the structure, but mainly the conducting material is silicon. And the reason why it's silicon again is because it's also a semiconductor. So when the electricity comes through and goes through one of these strands over here, it will not be able to leak. It will not be able to leak into the other strands because the silicon will have resistance blocking it and they'll all go through all the electricity will go through one strand. And the way that they made this silicon is through silicon nanowires. And so all in here, especially, it's just a lot of these. And this is what pure silicon looks like, and this is what it looks like on an IR receiver over here. The next part is the potentiometer. Now you may have seen this in physics where you connect this to a circuit and you can change the resistance and you can change the properties of the circuit. Now over here, potentiometers are mainly made out of graphite, which is basically carbon in a certain arrangement. It's also made of a resistive wire called nichrome. It's an alloy made of nickel and chromium, right? And the reason why they chose nichrome is because it has a higher resistance for a metal and an unusually high resistance to oxidation at high temperatures. So that's what sets it apart from silicon here. So they use this instead of silicon. And potentiometers, uh, the reason why they use graphite, which is carbon, they use a non-metal here. So usually carbon would not be able to conduct electricity because it's a non-metal, but in the shape of graphite, which is a carbon atom surrounded by three other carbon atoms, it does conduct electricity. Now, I'm not going to get into specifics why, but it's mainly because of this hexagonal structure that it creates with one in the middle and three at the sides. The three at the sides, and it creates a hexagonal structure. It makes it extremely smooth, and the excess amount of electrons allows electricity to flow through. And the reason why this is the reason why they also use it because it's smooth, so you can slide the potentiometer all along. And the reason why they need to slide it is because if you slide it, it can change the frequency at which the potentiometer receives signals. So it's incredibly useful. You can use one IR receiver to receive multiple different signals, albeit it's at different times. But the carbon in here is extremely good for a potentiometer like this. Now the last main part of an IR receiver is something called the LED transmitter. Now this is not a normal LED. It emits light in the infrared spectrum, and and the reason why an IR receiver has to have this is to establish a stable two-way connection a stable way connection between this and the controller. And it's mainly made out of indium gallium arsenide because it's a type of infrared light emitting substance, and it's compatible with silicon. It has a cover made of glass, plastic or glass over it to enhance the spread of the signal produced, right? And you may recognize this, this is like a circle or a tube on the front of a TV remote with a bulb sticking out. This is the LED transmitter you see, and over here is just a diagram of what it looks like. This is the gate. This is the gate or the transmitter, like the real transmitter. This is the source, and this is a drain where the electricity comes in through and out. And this is just the bottom plate. And all the electricity goes through here, and that's the indium gallium arsenide in here, and this is the gate. So the electricity comes through here, this emits the thing, and the electricity comes through the other way. And this is indium gallium arsenide uh in its pure form. Now, where do these metals come from? uh or not just entirely metals, all these materials. Now, silicon can be found mainly anywhere in the world, mainly because of how easy it is to make. So all you need for silicon is some sand and some carbon. So what you need to do is you need to put sand, chemical formula is SiO2, and carbon. So all you need is to put SiO2 and carbon in here and heat it to high temperatures so that the carbon displaces the silicon in here. And so it becomes carbon dioxide and carbon monoxide depending on how much carbon you put, and the silicon is extracted. For nickel, copper, and chromium, they're all found in mines. Chile creates the most amount of copper, Indonesia creates the most amount of nickel, and South Africa creates the most amount of chromium. But they can be found in a lot of other places, not just these. But these are just the countries that produce the most. But specifically for indium gallium arsenide, it's produced by this one American company by Alb Materials in Nevada, and they create most of it. So they're the main makers of this material. Now the production of these materials actually they have some problems behind them. Now, for nickel and copper, when they're mined in the Congo, it actually fuels a lot of violence. Now, what happens here is small anti-government militias in the Congo, they get slaves to work for them in the mines, and they take the mined metal and they sell it to big companies who are always hungry for cheap metals and ways to get more money. So they buy metals off of these militias, and these militias use that money that they got to buy new weapons and fight with those weapons. So the war is never ending with this slave mine going on. And another problem is that many heavy metals that are disposed or mined or leaked are extremely bad for the environment, even in small amounts. So and also mining in an area too much may cause instability of the land, and that leads to fast erosion and sinkholes, as we see here with this uh with this cattle farm over here. A large mine was nearby over here, and it caused a lot of sinkholes nearby. So not only does it affect the area of the mine, it also affects nearby areas, which is an extremely big problem. And when an IR receiver is disposed, what happens to it? Well, the silicon could be recycled, but that basically never happens because recycling silicon is more expensive than just creating new silicon. And also silicon doesn't even do that much harm to the environment because it's not like a heavy metal or anything. Um, the rest of the receiver is either recycled, incinerated, sent to the landfill, or exported to other countries to be dumped. Um, and that could also be a problem of itself. But the metals that a lot of metals that are dumped could accidentally be leaked into the environment, and they could cause major harm, especially in humans, because metals like beryllium and mercury can cause pneumonia and nerve paralysis, and we don't want that. And metals like copper and nickel, they could be recycled, so they don't really pose a threat to the environment once they're recycled. Hi, it's me again, and I thought it'd be nice to bring your attention to the multimedia part I made instead of listening to the boring part where I try to make a teaching video about IR receivers. Now, this is a Lego tank that I made, fully functional. Turret ring can rotate, suspension, tracks can rotate, and everything. And it's supposed to be a full representation of the Ripsaw M5 tank in Lego form. And the reason I did this is because I thought I could symbolize so many things in one object. Now, it has an IR receiver, which is an S brick, a Lego S brick that receives IR signals in it. It has the green light on it. And I thought I could symbolize how IR receivers the materials from IR receivers can come from conflict that come in the Congo, like warfare, just like how this tank symbolizes. And the tank structure can also symbolize how it's used for the military, like the Ripsaw M5. And it itself being built out of Lego can symbolize how it is educational, and just like because Lego is supposed to be an educational toy for kids, and also it's the fact that it's remote control can also symbolize how it's supposed to be for entertainment purposes, just like how little kids like to play with remote control cars and all this stuff. This is a remote control tank. It also could be provided as entertainment. I really hope you like it. I spent a lot of time on it, and God, it was an engineering and design nightmare. Most complicated most complicated vehicle I have ever made.